Okay, so this is the first part of looking at my TI6000 ARM Docker image. In the end of the video, I will show you how to install it directly, but let's just get on with using it. So what I've already done is to pull it down. You can get it directly from the Docker hub. It's installed there. And there's this TI command here. So what I do is I'm going to export my path, if I can type, to be where I am with the current path, And so what this means is that this is now TI command is now, if I go up one directory and I say which TI command, it will be the one in my shooking software TI command. So now if I go to my Zoom pedal fun software Zoom pedal fun, yeah. And if this goes to the MS70 CDR and let's go to the derived data and to the number and pants is where it is, there should be some ELF files in here. Okay, so these are the location format. What is a TI 6000? It's a processor that's used inside the Zoom pedals. So we want to export the TI folder to be the current directory. And what we're going to do, we're going to use the TI command to operate on the files here, but we're going to mount this file space inside the Docker, and then we're going to do the work inside the Docker with the TI command, and then it's going to store the exit or the output here if we want to. So let's just give an example of what it says here. We've made it, that's good, and we've exported the folder. So have we got an error? We have, there's an error elf there. So let's run this command, yeah? So this command here should extract the elf information. So Control Shift V to put it in. And this is passing it through to the Docker and it's running the Docker. So now it's pulled the information out and we can basically use this to pull out information and do anything we can do with the TI commands as if they were installed on a computer, and they are indirectly via the Docker, yeah. But this is the actual code it's using inside the processor. Oh, sorry, yeah, this is the assembler language. It will be passed down into the DSP to do its work, yeah. So yeah, it tells us about the thing. It tells us about we don't know what all these things mean in a minute, but we can begin to see more about it, like the tone editor. We can see the size editor. We can see things like the image icons are stored in here for on the pedal for drawing stuff. So what it does, it has a basic picture icon, and then as you move parameters, it will render the dial coming in. So this will hopefully allow us to look a bit more deeply. And why I'm interested in this, inside the binary, inside the ZDLs and therefore the ELF, there are certain floating point numbers stored there, and I want to pull them out so I can use this is the pick, yeah. So the pick effect type air, this is some semblance of the icon. You have to do a bit of work, and I've got another video about that based on some work by elinks, a Russian guy, and some Montreal uses a program in Python to pull out this elf, but this is how you can do it with the real toolchain directly. And what I'll do in a minute is I'll stop in a moment, and then I will put in a sped up version of how to build the Docker yourself if you want to do it from scratch. Yeah, the effect type image info and all these sorts of things. Yeah, so there's a whole load. There's the tail. If you put the parameter tails on, the what the effect nub does in reverse. Yep. So um, if I just do a pop directory, I think I did a push directory. Oh no, I didn't. So let's go to /software TI command. And if we look inside the TI command, which was generated by the install command, what it's doing is basically going inside. Yeah, so it's going inside it's running interactively. So in fact, can we do this TI command bin bash? I don't know if I've got that in there. Let's have a look. No, I can't do that because yeah, I am inside it. Okay, yeah. So if I am inside the image now, yeah. So if I go to /user bin, I think it is, then we got all the commands here that you'd expect, you know, like your disassemblers and your listings and stuff like that. So now we're inside the Docker, and what it's doing, it's using the TMP directory to do the redirection, yeah. And so at the moment, this will be mounted because of that environment variable. So this is now back inside the physical machine, but you see it's owned by this user 1000 inside the Docker. Outside, it's owned by us. And what the script is doing is mapping the users so that we don't end up basically having your files owned by root or whatever. Yeah, this is what the user group does. So it makes life easier for you. And yeah, you can download someone that Docker already have, or you can create your own, and you can run this as a resource. And you know, if you decide you don't want to do this, you just remove the Docker and you haven't changed your system. Yeah, and it's much neater than installing stuff locally. And you can run this trick on ARM. This is ARM64, so you can do this on a Mac natively because that's what the M2 chips are, M1, M2 chips, or you could do this with x86 if you so wish, yeah, but you'd have to change the pool. So I'll put the other bit of the video in. Have fun, enjoy. Thank you, and please like, subscribe, or send comments. Bye bye. Hi. So what I want to show you now is something I did a little while ago, but a bit of it busier. So a TI6000 ARM. What is a TI6000 ARM? This is the Texas Instruments toolchain for processing the older cold-fire type processors, the TMS chips that are used inside the Zoom pedals. And you can go to my Docker here and pull it down, and we'll do it now. Yeah. So what I've done is I've cleaned out my cache completely. I did it with this command here. You don't need to do this. This was just what the Docker system -a. Let's just do it real time. What I'll do is I'll make this video and then I'll put it at the end of a short video, and I'll speed this bit up so you can see the full process. Yeah. So we want to basically get this code down, git clone Control Shift V, bang. And then we want to cd into the TI, and if we say docker images, we haven't got anything here at the moment. Actually, I've lost my portainer. I have to put that back in. Yeah, that's fine. So now we want to look at the code, and it has a make file, and so it's going to do a couple of things. It's going to make a Docker image. You can download it directly from the Git repository. It is there. And you can, and once it's installed it, you'll have a TI command which you'll use as your entry point into the Docker, and you just need to put the uh, either copy it to your use the local bin or put a path to this, and then you can basically you issue commands via the TI command and an environment variable, and the directory is operated on inside the Docker, and the data is pushed back as the current user. So it makes life fairly simple for you, and you can install later versions if you want just by modifying the code. So let's get on with it. So if we do a make, it will now go through. It can't find the image, so it can't remove it. And now it's going to go and build it from scratch. But you could go to the Shuking Sybase TI6000 Docker AR64 and pull it directly from the Git repo. So now what it's doing is curling down the latest download of the toolchain for, in this case, the AR64. I haven't tried it with a later, I haven't tried it with a different operating system, but it should work. So I'm going to shut up now, and I'm going to speed this up by the magic of video editing, and I will be back when it's done. Okay, so now it's installed the command, and now we have this TI command. If we run it, it might work. It might not. Normally it will complain that there's a problem. Actually, it doesn't for a different reason. But anyway, that's it. It's installed it. And if we do Docker images, we can see that we have it installed, 343 megabytes. And yeah, that's how you build it from scratch. This will be at the end of the video, and thank you for watching. Bye bye.